Hey everyone, welcome back. Before we get started, if you're enjoying these videos, please subscribe to my channel. It'll really help me make some more of these videos for you. Also, I'm trying out different background colors and font colors, so you can write in the comments which ones are easiest to read. Alright, let's get to work. This is the third problem from the differential equations chapter of cracking the GRE math subject test. It's a little bit trickier than the first two problems, but it's not that bad. First of all, just to help understand what they're asking you, it helps to draw a picture. So you're looking for a function like, let's say, y equals f of x. Let's just draw some kind of random function here. And what they're saying is that if you take any point on the graph and you draw a rectangle from 0, 0 to that point, xy, then the area under the graph is equal to 1/3 of the area of the rectangle. Well, that just means that the integral of the function with respect to x is equal to 1/3 of the rectangle, which is x times y. That's the area of the rectangle. Okay, so you have to solve this problem. Now, if you differentiate both sides, you want to find y. If you differentiate both sides, well, the derivative of the integral of y, that's just y. So you get y is equal to the derivative of, with respect to x, of 1/3 xy. Now the 1/3 comes out in front, and the derivative of xy, you have to use the product rule. So the derivative of x is 1 times y plus x times the derivative of y with respect to x. So our equation is y equals 1/3 times y plus x dy dx. And this is what's called a separable equation because you can get all the y's and dy's on one side and all the x's and dx's on the other side. So let's try that. If we multiply both sides by 3, we get 3y equals y plus x dy dx. And then if we subtract y from the left side and the right side, we get 2y equals x dy dx. And then if you multiply both sides by dx, divide both sides by x, and divide both sides by 2y, you get dx over x equals dy over 2y. So this is a separable equation. You see we got all the x's and dx's on one side and all the y's and dy's on the other side. And now all we have to do is integrate both sides. Now the integral of 1 over x, that's just, let's move this up a little bit. That's just, let's continue over here. That's just the natural logarithm of x plus some constant. And the integral of 1 over 2y, that's just 1/2 times the natural logarithm of y plus some constant, but I'm not going to write that because we already added a constant on the left side. Now, if we take the exponent of both sides, then we get e to the log of x plus c equals e to 1/2 log y. Well, e to the log of x plus c, that's the same thing as e to the log of x times e to the c. E to the log of x is just x, and e to the c is just, it's still another constant. Alright, c. And then we get e to the 1/2 log y. Well, From the properties of logarithms, we know that this 1/2 can go up on top of the y here. So it's like e to the log of the square root of y, which is just square root of y. And if we square both sides, we get y equals cx squared, but c squared is just still a constant, so, oops. I don't want that. That's supposed to be a c. Let's get rid of that. C. Ugh. C. And that's one of our answers. That's answer D.